Just a notation for you. An implication, like for every x in domain D, Px, then Qx is called vacuously true or true by default. Or true by default. If and only if Px is false for every x in D, x in domain D. Just a quick note for you, vacuously true or true by default. So here you have an implication for every x in domain D, Px implies Qx. We say that this implication is vacuously true or true by default if and only if your hypothesis Px is false for every x in D. And another note for you, when it comes to inverse, converse, contrapositive, you're going to have universal statement. Note that. Let P then Q be an implication. Very well. Remember that we defined the converse as Q then P. It's going to be for any x in D, Qx implies Px. This is for the converse. For the inverse, we had not P, then not Q. It's going to be another implication for x in all x in domain D, not Px implies not Qx, and finally the contrapositive. Not Q, then not P. For every x in domain D, not Qx implies not Px. Now, all of these are universal statements. Remember that in order to find the negation, you have to convert them into or and then find the negation for each. So if I ask you to find the negation of the converse, the inverse, the contrapositive, we need to rewrite each statement in or, then use the negation. Let's go over one example together. example. How do we translate sufficient condition and necessary condition? Suppose I give you the following. For any real number being larger than 2, is sufficient so that the number is larger than 4. How do we translate this? What's the mathematical, logical form that we use for sufficient condition? In general, you can say that for any x, px is a sufficient condition for qx, meaning that for every x in the given domain, if px, then qx. So when you have one condition as a sufficient condition for the second statement, it means that you have your hypothesis here. Another one is the necessary condition. For any real number, for example, being larger than 4 is necessary to be larger than 2. Okay. We're not discussing if the statements are true or false. We're just using the sufficient and necessary keywords in translating mathematical statements into logical form. Well, when you have the necessary condition for any x, px is necessary condition for qx. What's the meaning of that? It means that for every x, qx implies px. So your necessary condition is going to be your conclusion. The sufficient condition is your hypothesis. The necessary condition is the conclusion.